Hello everyone, this is Kalema Alan, and today we are going to talk about machine learning operations and how they can be used in the heart disease detection system. First of all, machine learning operations, also known as MLOps, they briefly on their description, they automate the life cycle of machine learning models, and by carrying out the following: there is development and training and refining models, there is deployment, moving models to production seamlessly, and there is monitoring, whereby they track the performance behavior, scaling, that's adapting to the workload variation, and maintenance. And the importance in healthcare, there is automated data management, whereby ensuring high quality data. There is CI and CD, continuous integration, continuous implementation, where the automation model, there is automating model training, testing, and deployment for rapid updates. There is performance monitoring, there is explainability and trust, whereby providing insights into the model prediction to build the trust, and version control or rollbacks, managing model versions and enabling easy rollbacks. Rollbacks is when there is an error and they they try to revert the code. Improving data detection, accuracy, and transparency, since those are one of the key values that we want to implement in our system. We use the following. There is explainable AI. These techniques, such as Lime and Sharp annotation mechanism, enhance the trust in models by explaining predictions and aiding clinicians in patient-specific interpretation. There is active learning. Active learning optimizes the model training by prioritizing uncertain data points for expert labeling. This enhances the accuracy for fewer training samples. And there is federated learning. Federated learning trains the models on decentralized devices without sharing raw data to preserve the patient's individuals. We also seek to enhance the scalability and performance, and we can do this by using through containerization, cloud deployment, and monitoring. Containerization, in this sense, is where they package models, dependency, and runtime environments in a container like Docker, which ensures consistent portable deployment across diverse environments. Cloud deployment is utilizing cloud platforms such as AWS, there is Azure, and GCP. This provides on-demand resource and scalable capabilities, ensuring efficient handling and fluctuating workloads. Monitoring. Continuous monitoring tracks and key metrics such as models and performance resource usage, and data drift, enabling proactive issues detection and resolution. DevOps and data ops. DevOps simply emphasize the collaboration and communication between development and operations team to streamline software delivery. While data ops applies DevOps principles to manage data throughout the life cycle. And we talked about, and we are going to talk about the heavy MLOps and emphasizes collaboration. I will talk about the heavy MLOps and light machine learning operations. Heavy machine learning operations involve complex infrastructure tailored for a large-scale deployment with intricate governance needs. It utilizes specialized MLOps tools and platforms for comprehensive model and management. While light MLOps prioritizes agility, employs simpler tools for rapid experimentation and deployment. It relies on open source resolutions and cloud-based services. Then choosing the right approach between the light or heavy. It will depend on the project size and complexity, the team expertise, and the budget and resources. Well, DevOps in the timeline. In other words, how is DevOps or data ops applied in my project? Well, it automates the building and testing and deployment of the model code and associated infrastructure. It ensures a smooth collaboration between data scientists and engineers, and it manages infrastructure provisioning and scaling based on requirements. Data ops ensures high quality data ingestion preprocessing, and feature engineering. It also implements the version control and lineage tracking for auditing and productivity. Now, MLOps hierarchy of needs and maturity mode. We have three. We have reactive, proactive, and optimize. Reactive models are deployed manually with limited monitoring and intervention. Proactive automation is introduced for tasks like deployment, testing, but monitoring remains reactive. This improves the efficiency for lack of continuous improvement. And optimize, we have continuous integration, continuous delivery, automates the entire life cycle with proactive monitoring. Those are the hierarchy from reactive to optimized. So integrating needs for the high detection disease detection system. In the needs, we have data security, model explainability, performance monitoring, and regulatory compliance. Under security, we integrate data governance and anomaly detection to address data poisoning threats. In explainability, implement the explainable AI techniques to interpret prediction and build trust. We also have the performance monitoring is continuously monitor accuracy, fairness, and drift to maintain optimal performance. And for regulatory compliance, we align with relevant healthcare data privacy regulations. So strategies for data integrity and microservices. We have data poisoning. The strategies we can do for data poisoning, we have data validation, where continuous checks for the data quality are made. We have anomaly detection, where we use algorithms to detect suspicious patterns that might indicate tampering. And also we have auditing and lineage. Here we track the provenance to identify the potential manipulation data points. Then for data drift, it's right here. For data drift, we have regular model training. Here we retrain the model periodically with fresh data to adapt to concepts and changes. We have drift monitoring. We track key metrics to identify the performance, degradation, and for indicating potential drifts. And we have active learning. Here we query experts for labels on uncertain data points to improve. And operationalizing microservices. Under this, we have modular design, we have independent scaling, and we have fault isolation. These are the ways how we can overcome operationalizing microservices. Under modular designing, we break down the system into independent self-contained services for flexibility. For under independent scaling, we scale individual services based on their specific resource. Fault isolation, we issue one service, don't impact others, improving system reliance. CI/CD features and store project and Python project files. We automate, under CI/CD, there is automate testing and deployment. We have version control where we track changes and rollbacks are carried out. We have faster updates, continuously updating. Under feature stores, we have centralized management. We store and manage features used by models in centralization. We have versioning and governance, and we have improved efficiency. Under key Python project files, we have data files, of course, raw data used for the training and testing. We have the model code, Python scripts, and training the models. We have configuration files, setting for training, hyperparameters, deployment environments, evaluation scripts, code for calculating the model and performance metrics. We have the deployment scripts, evaluation, deployment, configuration, model code, and data files. Thanks for watching. This is my work.